Hi guys, it's Miss Morgan. In this video, we are going to talk about 1.4, flow of energy. So by the time you finish this set of notes, you should be able to analyze the flow of energy through trophic levels, and you should be able to interpret food chains, food webs, and food pyramids. All right, so before we get started, a little alert for you guys. This segment of notes is super vocab heavy. So I'm going to warn you to proceed with caution and maybe grab a glossary if you need to help you out. But be sure you write those vocab words down. All right, so what's eating you today? Well, hopefully nothing because you're human and you're pretty much at the top of the food chain. But in order to name the things that are in a food chain and a food web and be able to talk about them, we have some vocab terms. So first we're going to start with producers. Producers are at the bottom of the food chain in the food web, and they are autotrophs, meaning that they can produce their own energy using some resources. So photoautotrophs are going to be your green plants, and they use light in order to convert solar energy into usable energy. Photo means light. You also have chemoautotrophs, and they're going to use chemicals, and they're going to convert the energy from the chemicals that they consume into a different form of chemical energy that they can use. And you're typically going to find the chemoautotrophs living in places where the sun can't reach, so especially in those deep sea vents. Now, on the other side of things, you've got consumers. Consumers are what's going to be taking in energy from something else. They can't make their own energy. So they're going to take energy from something else and convert it into a usable form for themselves. So you've got herbivores that primarily eat plants, carnivores that primarily eat meat. But remember, we're not just talking about meat like a steak or a piece of fish. This could be one insect like a praying mantis eating another insect. You also have omnivores. They eat both meat and plants. And then you have saprotrophs, and they are decomposers. So they're going to absorb their food by breaking down dead organisms. Now, we name our consumers based on when they consume something. So, primary consumers directly get their energy from a producer. Secondary consumers directly get their energy from a primary consumer, and tertiary consumers directly get their energy from a secondary consumer, and quaternary consumers get their energy from a tertiary consumer, and quaternary consumer. Well, anyway, you get the point, right? We name things for the order in which they consume their energy. Okay, so why don't food chains go on and on and on and on and on? Well, that's a great question. So each step in a food chain or a food web is called a trophic level. So here's a list of the trophic levels. Now, a food chain is a series of steps by which organisms transfer energy by eating or by being eaten. Now, remember, they're not always consuming through a mouth. Sometimes they're absorbing. So, for example, starfish actually invert their stomachs into their prey. And they secrete a little digestive juice and break it down and make it all like slimy, and then they absorb that back up. So, it's not necessarily eating through a mouth like we do with chewing. It's a different form of consuming. But no matter how organisms consume, they're getting energy. And the arrows that you see in a food chain are all about showing the direction of energy transfer. That's super important. So let me say it again. The arrows in a food chain or a food web show the direction of energy transfer. Now, when we're talking about food chains and food webs, there's something called the 10% rule, and this is crucial to understand. Each time we move up a level in a food chain, only 10% of energy is passed from one trophic level to the next. That means 90% of the energy is just lost, mostly to heat and other metabolic processes. So that energy can't be used to do work. It's just gone into chaos in the universe. Well, that doesn't seem like a big deal, right? Until you put it into terms of actual amounts of energy. So you can see at the bottom level, these grasses have 10,000 joules of energy. But when the grasshopper consumes that, the grasshopper is only going to get 1,000 joules of that. And then from there, that predator wasp is only going to get 100 joules. Remember, we're only transferring 10% of the energy from level to level. And that big old frog is only going to get 10 joules. The snake who eats the frog only gets 1 joule of energy. And when that hawk eats that snake, that hawk is only going to get 1/10 of a joule of energy. So that hawk's going to have to consume a lot more to get the amount of energy it needs to carry out its own metabolism. So I guess what this really boils down to is we now have an explanation for why the lion really sleeps tonight. Okay, I'm sorry, bad joke. Well, then let's move on to food webs. So, if I take a whole bunch of food chains that exist in an ecosystem and I put them all together to show the interactions between the organisms, that's called a food web. An organism can occupy multiple trophic levels in a food web. So here's some examples of that. You can see the little turtle there at the bottom of the screen is actually occupying 2 levels. The turtle is a primary consumer because it's eating the water weed and getting energy from there. But it's also a secondary consumer because it's consuming the fly and the slug for energy. So organisms can occupy multiple trophic levels based on the combination of different food chains and their different eating habits. So the turtle would be an omnivore. All right, last but not least are the 3 types of ecological pyramids: the pyramid of numbers, the pyramid of biomass, and the pyramid of energy. We've already essentially looked at a pyramid of energy, which shows the available energy in a trophic level. So as we move up the pyramid of energy, the amount of energy available to the next level becomes less and less due to the 10% rule. You can see that in a pyramid of energy, the base is very large because there's plenty of energy available to the system. But as we move up, the energy gets less and less. Hence why the lion sleeps a lot, because it's just not getting a lot of energy. Now, the pyramid of numbers and biomass can change and typically do not look like a true pyramid or a true triangle. So, for example, the pyramid of numbers on the left is showing you how many organisms are in that trophic level. So, we might just have a single oak tree or a few oak trees in a park, making their number very small and the base of our pyramid very small as well. Caterpillars, however, there can be tens of thousands of those, so their numbers are much higher, so their level on the pyramid is quite wide. The bluebirds that are eating those caterpillars, getting the energy from there, are going to have fewer in number, but there's still going to be more birds than there are oak trees in this ecosystem. So their number is going to be creating a level that's kind of in between the caterpillar and the oak tree. Again, it's based on the number. So there might be 10,000 caterpillars and 50 bluebirds. And then finally, that top predator at the top of our pyramid, there may only be 1 or 2 of those. So again, their level of the pyramid is very small. Now, biomass is what it sounds like, the mass of life or life mass. This is the mass of the organisms at each trophic level. So oak trees weigh quite a lot because they're a very massive organism, so they're going to have a very large base. Caterpillars, even though there may be tens of thousands of them, they don't weigh very much because they're quite tiny, so their level is a little bit smaller. Same thing with the bluebirds, fewer of them and lower weight, so they're going to be a little smaller. And finally, our top predator is the smallest. Now, biomass pyramids are interesting because they can do a little flip flop. Sometimes they'll be inverted when you see them. Don't let this throw you off. What it's telling you is that most likely the producers in that ecosystem are teeny tiny, like phytoplankton in the ocean. They're so tiny that they're not very massive at all. Whereas the carnivores, that are going to be things like your orcas and your sharks, are huge organisms, very massive. So they're going to have a much larger top level. All right, so we're almost to the end of the notes. Don't forget to look at your notes checklist and make sure you're squared away before you come to class the next time we meet. And I hope you have a fantastic day, and we'll see you in class next time.